Hi everyone. In this last session of today, Fabian Meumertzheim, a software engineer at Code Intelligence, I'll talk to you about a very fundamental concept and feature in Bazel, that of run files and the mystery of how to find them. So let's dive in. So first of all, what is a run file? We're looking at the example of a fictitious rule set called rulesGrow. And that rulesGrow rule set has a farmer. And this farmer, being a farmer, needs access to seeds to do their job. And because this farmer is operating at scale, for some reason it also needs access to proto-C. Whatever, everything needs proto-C. So this is just a regular CC binary. It has data, and that means that Bazel, when building this target, will make everything in data built and available to this target at runtime. That's nice and everything, but how does that actually look like? So if you are on Linux or macOS, then there's a flag called enable runfiles that will implicitly, even if you don't specify it, default to true. And what that will do is it will give you right next to your farmer binary a farmer.runfiles directory that mimics the structure of all your repositories, your main one and the external ones, has all the assets in there, regardless of whether they are source or generated files, neatly arranged in a directory tree of symlinks. You have well-known relative paths at which, for example, the farmer binary could access proto-C. That's all nice, but what about Windows? On Windows, symlinks are they used to be not supported, then they were supported but required admin access. Sometimes they need a flag, whatever, it's complicated. And above all, they are slow. So what Bazel does is, if you build on Windows, then this flag has a different value by default. And what you get is a manifest file. It's called like your binary.runfiles manifest, and it has one line for each run file, which essentially has what used to be a symlink, just explicitly written in a file and a text file. That's more cumbersome to deal with. Like, you can't just access files, they just won't be there. So you need some custom logic to work on Windows. But then things get more complicated with a new feature, Bzlmod, which is otherwise quite great. That will be in Bazel 6. Because Bzlmod makes extensive usage of repository mappings, what you think is the repository name of something is actually not it on disk. So if your rulesGrow Bazel module depends on protobuf in version 3.19.2, it could end up resolving in the resolve dependency graph to protobuf 3.19.6, and suddenly you get this weird thing down there that you certainly don't want to hard code in your Bazel module. So what are we going to do? How to make run files work? Luckily, there's an answer to it. Somebody who's unfortunately no longer working on it, Laszlo, started an initiative to provide run files libraries, small Bazel library targets for each of the popular languages that would automate this job of resolving a logical run file path to an actual path on disk for you, so that you can focus on farming and growing seeds and whatever, and don't have to worry about all these situations. Because, to be honest, there's a pretty large feature matrix. You have to cover platforms, Linux, macOS, Windows, non-default settings. Your thing can be run as a build action, as a test. You can just run it from the output tree. It can run as a sub-process of something that does. And then with Bzlmod, you need to translate user-speaking repository names, such as protobuf, to this abomination down there. The good thing is run files libraries exist for many languages, and they take over this job and make it easy to use run files. So what do? Because they're implemented in all these different languages, their exact APIs depend on the particular programming language. There are different idioms that you use. Some languages are compiled, some are dynamic. So the exact interface will always be a bit different. But generally speaking, there are these three functions. There is a create function that gives you some kind of a run files object, whatever. That just parses all the metadata, tries to locate the manifest or the directory, whatever exists, parses some file that serializes the knowledge about Bzlmod's repository mappings. And then you have this file with all this information, this object with all this information. And then you can use the rlocation function. And that's the one term to keep in mind from this talk. Rlocation translates a path such as repository name, some package further down the tree, file name, to the actual location on disk, which may be a relative path or an absolute path, but something that you can resolve and use freely, and you will find the file. And then, because I claimed that this also works with sub-processes, but some people may know Bazel doesn't build Runfiles trees for anything but the top level target that you actually ran. They're all merged together, which means that if you want to run this for a subprocess, there are some environment variables that you need to set. But with Runfiles libraries, that's easy. You just run a function that's called n for nvars. It gives you a list of environment variables. And as long as you always, even if you think you don't need to, always set them for subprocesses, things will just work. And Runfiles libraries in these subprocesses will be able to find Runfiles as well. OK, now that we see what this looks like, let's actually look at an example. And here's the thing, Bzlmod is a new feature. So some of this and some of the APIs are only available in Bazel 6. So in all these code samples, I'll always point out what's supported in what version of Bazel. And here we have our pharma binary upgraded to support Runfiles in a backwards compatible way. So we actually cherry-picked some features into the 5.4 release so that people could have an easier migration path. You may know location expansion, these dollar patterns from something like root path or exec path or location. If you mention our location path anywhere in an argument or an env setting on a rule, it will resolve to this path that we just saw, this repo name, package, and so on, with all repository mappings applied, everything for you. That's the thing you need to pass to our location. So here in this example, we have a dependency on the C++ Runfiles library, and then we explicitly pass in the our location paths of these two files. And what do we do in code? Well, we use the C++ Runfiles library. There's actually a lot of documentation in that header file that you can read, but essentially you just do runfiles create. In this case, in the case of C++, this needs argv0 for some reasons. You pass it in. And yeah, then you can just do runfiles our location of the thing that our location path gave you, either in an environment variable or in an argument. That works, and that part is also supported in all versions of Bazel. But then there is some problem with that, because that relied on having something passed in via an environment variable. That works well if you control the binary, but it gets very tedious if something very far down your dependency chain, some CC library somewhere needs a run file. So there's a way around that, which requires Bazel 6 to work with Bzlmod. So there is a new constructor or method called create that takes a second argument. And that second argument is sort of your point of reference from where you're interpreting user-speaking so-called apparent repository names. And it uses the repository mapping that it has serialized internally to map that to the actual path on disk. And luckily, we added a magic macro. Who doesn't like magic macros? Called Bazel current repository to all CC rules. So that's a macro, and that value has always the right canonical repository name to use as a context. So you can just create a runfiles object, and then you can use user-speaking or user-facing paths like protobuf. You don't involve the version in anything. So these paths are now safe to hard code in your code and use in libraries, and you will find runfiles. But take into consideration that if you want to support Windows, you may have to add the file extensions there. And because this actually got merged in time for this talk, I get to go to my backup slides and tell you about how this looks like for Java, the other major rule set supported by Bazel. There, with essentially the same definition as the CC binary, just as a Java binary, you can pass in the value of our location path. And then in Java, it looks really simple. You can just use the argument value, pass it into the allocation function. And now there is also a Java equivalent of this Bazel current repository mapping that allows you to just write the paths in your code. Because it's Java, there is slightly more setup. So we actually came up with an annotation that you can put on your class, and that generates a class for you called auto Bazel repository _ class name. And with that, you can just get the Bazel repository that contains this class, which is a weird operation if you think about it, but it's what makes Runfiles libraries tick. And then there's a fluent interface to construct a Runfiles object that you can then use to look everything up. As I said, this requires Bazel 6. So yeah, to summarize, Runfiles libraries are great. You should be using them. Everybody on Windows will thank you, because at the moment, many things in the ecosystem are slightly broken because they assume this Runfiles directory layout. If you use them, you're on the safe side. And at least with Bazel 5.4.0, you should be able to use them to the full extent and be compatible with Bzlmod. And this is just a list of all the Runfiles libraries out there. They're in different states, like not everything's perfect. Some are not ready for Bzlmod yet. If you are a ruleset author or just like interested in getting this to work, come find me and talk to me. We can probably improve the situation together. Yeah, thank you very much.